All right, this video is going to talk about what we call the triangle inequality theorem. The triangle inequality theorem is going to tell you that the sum of the lengths of any two sides of a triangle must be greater than the length of the third side. So when we take a look at this diagram, we're going to go ahead and use three colors. That way we can see even more clearly the correspondence. So if you'd like to pause and grab a few colors, it'd be a good idea. The first thing we look at here is I'm going to go ahead and take segment QP. I'm going to outline it in my pink color. And I'm going to find each PQ over here and just kind of underline it. And I'm going to do the same thing for segment QR and PR. So here we're saying, okay, if we take the length of PQ plus QR, when we add them together, it has to be greater than the length of segment PR. Same thing with, we take QR and PR, we add these two, has to be bigger than this third side. And then if we take these two right here, QR and PR, they have to add, when we add them, they have to be greater than this. So when we take a look here at some examples, whenever I do this, I generally will just take the two smallest sides, because if you take the two smallest sides, you'll get the smallest sum combination. So I take the two smaller sides, add them together, and compare it to the larger side. This will work, and it prevents you from having to do three different inequality, having to add it 3 different times. So whenever I set this up, I will take the two smallest, the 8 and the 15 in this case, and I'm going to say, okay, 8 plus 15, and then I put this circle here. In that circle, I'm going to have a greater than, less than, or equal to sign. And I'm going to take the larger side and put it over here. When I add 8 plus 15, we're going to get 23. And I can see that 23 is greater than 17. So when it says, is it possible to form a triangle with the given side lengths? If not, show why not. This is showing your work why or why not. Okay? So this right here, since the sum is greater than the longest side, or the third side, we can say yes. This is going to be a triangle. So picking up the pace here, I'm going to take my two smaller sides, 6 plus 8. I'm going to compare it to the third side. 6 plus 8 is going to give me 14. I'm going to notice that the symbol that goes in that little circle is an equal to sign. This is not, the sum is greater than. So this will not form a triangle. So it'll answer no. Letter C, same thing. Doesn't matter which two sides, but like I said, I take the smaller two because that's going to be the smaller sum. Here we've got the 9 plus 8. Let's compare it to the third side. 9 plus 8 is going to give you 17. 17 is greater than 10. So we have confirmed, yes, we do have a triangle formed with these. Last one, I've got the 10 and the 3. Compare it to the third side. This will end up being 13, and this is going to be less than the third side. So this will be another example of no. So we have two examples of yes. We've got an example of no where they're equal. We've got an example of no when the sum is less than. Now another thing we can do is we can figure out what a range is. So if I give you two side lengths, see here, when given two side lengths of a triangle, you can figure out that range. So it should be greater than one number and less than another. So if I give you the two sides, you can't say, okay, I know exactly what the third side is. You can't, but we can give, hey, it could be between these two numbers, greater than one, less than the other. So here we have a triangle. This is going to be a guided example here, step by step. A triangle has two sides measuring 4 feet and 8 feet long. What is the range of the lengths of the third side? We can just ignore that part. I forgot to delete that off the notes. I apologize about that. First thing we're going to do is going to draw a diagram to represent the situation. So what this means is we've got a triangle of some sort. We don't know what kind. We're going to label our unknown variable x. So we have two sides, 4 and 8. And then our third side is going to be x. According to the first page that we looked at, where we had the sum or sums of our angles of sums of two sides being greater than the third, we technically have 3 inequality statements that we can write. And that's what we're going to do right here. So if we take any two sides, let's say 4 plus 8, it has to be greater than the third side of x. Then let's say we take 8 plus x, add those two. This still has to be greater than 4. And in the last two, your 4 plus x would have to be greater than 8. So when we solve these inequalities, we're going to find out that your 4 plus 8 is going to give you 12. So x has to be, 12 has to be greater than x, meaning the side cannot be 12 or more. So let's keep this number in mind. When we solve this inequality, we subtract the 8 from both sides, we're going to end up with x is greater than -4. We are going to ignore this number here. Okay, we're going to ignore, let's go ahead and note. We're going to ignore because our side lengths cannot be negative. So we'll write cannot be negative. And then the last one, if we were to subtract that 4 from both sides, x is going to have to be greater than 4. So the positive numbers, the 12 and the 4, we're going to focus on that. So next we ask ourselves, which two numbers must the missing side length x be between? And so we're seeing here it needs to be between 4 and 12. 4 being the smaller number, we'll label that one first. So it has to be between 4 and 12. It's got to be greater than 4 but less than 12. So that's what we're going to go ahead and make our compound inequality, saying that exactly what I just said. X has to be bigger than 4 but less than 12. And this is the inequality to show, compound inequality to show the range. So instead of having to do all three of these steps, showing these inequality statements, we can simply do it this way. To find the range of the measure of the third side of the triangle with the sides 5 and 11, what we want to do is we want to find the difference between these two numbers. Okay, so we're going to take 11 minus 5, and we're going to end up with 6. And then we're going to take the sum of the two numbers, 11 plus 5. This will give us 16. X has to fall between these, more than 6. So here we're going to say x is greater than 6 but less than 16. And that's all you need to do to write your compound inequality for the range. Example number 4, we're going to have, if the measures of two sides of a triangle are 3 and 7 feet, which is the possible whole number measure for the third side. So we're looking for the whole number. One of these will fall within that range, the others will not. So again, I'm going to go ahead and abbreviate difference, but let's go ahead and figure out what our range is. The difference, I'm going to take 7 and 3. I'm going to find the difference, 7 minus 3. We're going to get 4. We're going to find the sum. 7 plus 3 will give us 10. So x has to be greater than 4 and less than 10. So we look at these and say which one of these falls between those, and that will be 5. 10's too much. 4 is exactly our difference, which it can't be either one of these numbers either. It has to be between them. And then 3 is too small. The other thing with your triangle inequalities, dealing with your sides, we're going to start talking about the comparison with sides and angles. Given the triangle inequality theorem, you can order your angles and sides from least to greatest or greatest to least with what we call the angle-side relationships. One of them states that if you have one side of a triangle is longer than another side, then that angle opposite of the longer side is larger. So the way I say this is the smallest is across from the smallest, the largest is across from the largest. So we need to remember that across from every side of a triangle is an angle. Across from every angle is a side. This is how triangles work. So looking over here, we're seeing that, well, actually, let's go ahead and look at this first. You're going to also see me labeling S, M, and L for small, medium, and large, or small, middle, and large. And here we only have 2, so we're just going to have small and large sides. 7 is your smaller number. 9 is your larger number. Across from the 7, the smaller side is your smaller angle. Across from the larger side is going to be your larger angle. So you can compare these two and know which angle is bigger and which angle is smaller. So here we have if XY right here is larger, they're greater than YZ, which it is, we can determine that while the angle across from XY, angle Z, is going to be larger, greater than angle X. And then we have technically the converse of it, okay? Across from the smallest angle is the smallest side. Across from the largest angle is the largest side. Right now we're just looking at small and large. So at angle K, we have our smaller angle. So you go across to the opposite side, you have the smaller of the two sides. Here, angle J is 110. It is the larger angle. Across from it is the larger side. So with measure of angle J is greater than the measure of angle K, as we can see. So across from angle J is segment KL, so the length of KL is going to be larger than across from angle K, JL. If we're still a little confused, rewind, look at it again, or let's go ahead and look at some practice problems. Example 5 here is going to give us these 3 angle measurements. We're going to go ahead and put them in, and then we're going to name these from longest to shortest. And technically this one's just asking for the longest side and asking for the shortest side, but then the last one is going to be that middle one. Or no, sorry, it says name the longest and shortest sides. So angle A is 120. Let's go ahead and label that 120 degrees. Angle B, don't really have a whole lot of room to write it in here, so I'm going to say angle B is 40 degrees. Angle C is going to be 20 degrees. So looking at our angles, we have all 3, so we're going to have an L, M, and S, or S, M, and L, your small, medium, and large. The smaller angle right here, angle C, is going to be the small. 40 is the medium or middle number, so this will be our M. And then A, 120, is the larger number. So going across, your smallest side across from the triangle is your smallest angle across is the smallest side. Your medium or middle angle across from it is going to be the middle side. And then here across from your large is your larger side. It's kind of a small triangle, hard to wedge everything in there. So your longest side, look for the L, we have segment BC or segment CB. Shortest side, this is where those S's, L's, and M's really help out. Shortest side right here is going to be segment AB or segment BA. And we've got one more. Example 6 is asking us to go ahead and classify the triangle by its sides and then list from smallest to largest. Whenever I see this ordering, smallest to largest, biggest to largest, things like that, I always want to remind myself by 1, reading it, 2, highlighting it, so now we got a second time seeing, and then also I like to put S arrow L, because this is one of the most common things is we accidentally go in the wrong order. We'd accidentally go largest to smallest. So we want to make sure that we see it over and over again. First of all, classifying by its sides, we're seeing that we have 3 sides that are not congruent. No congruent sides at all, so this is going to be your scalene. Now, in example 5, we had our angle measurements. Now we're looking at our side measurements. So let's find the smallest side, the medium side, and the largest side. So across from the smallest side is going to be your smallest angle. So here we're going small, medium, large. Smallest angle is angle B. M, the medium side, go across to the opposite side of the triangle. We will run into the medium angle, angle C. And then your largest side, go across to the opposite angle, and angle A will be our largest angle. So ask your teacher for any questions. You can also search YouTube, etc., for other videos for extra help.